Aloha, I am Tanadchangsaeng from Hawaii Natural Energy Institute, the University of Hawaii. In this video clip, I will briefly present our published research in the title of Microbial Synthesis of Polyhydroxybutyrate from Glycerol, focusing on gluconeogenesis, molecular weight, and the material property.
As we all know, the petroleum-based plastics cause many environmental problems. Therefore, bio-based plastics can be served as the next generation materials to replace the conventional plastics, since they can be produced from renewable resources and have complete biodegradability in the environment. Polyhydroxybutyrate, or PHB, is a biodegradable polymer containing ester monomer unit and can be produced from renewable carbon sources for bacterial storage. PHB is also a thermoplastics and biocompatible material with desirable physical properties. Selection of the suitable carbon source in biosynthesis is one of the most important factors that can reduce the cost of PHB production. Glycerol, as a byproduct of the biodiesel production, is considered as an inexpensive carbon source for the bio-based materials. So, producing PHB bioplastics from crude glycerol should be a competitive way for recycling the waste stream and reducing the high production cost of the PHB. Normally, PHB production from glycerol has low yield and low productivity when compared to the PHB production from glucose. In this work, we study the cause of limitation in PHB production from glycerol in the high cell density fed-batch bioreactor. Since glycerol is a non-fermentative substrate, we suspect that there are alternative products during the synthesis. So we can identify the metabolic intermediates released from the cells and accumulate in the culture medium during the cell growth by NMR spectroscopy. And we found that the bacterial cells can synthesize glucose from glycerol, and the glucose increased with cultivation time in the higher cell density fermentation. So we can indicate that some of the glycerol were utilized for gluconeogenesis pathway, and the glucose waste was released in the culture medium. Here we show an influence of the gluconeogenesis on the cell mass reduction and biopolymer productivity. Under physiological stress, such as nutrient limitation during PHB biosynthesis, the glucose were released without utilization and result in a lower cell growth rate and a lower yield. So we can conclude that for the glycerol utilization, gluconeogenesis is a crucial part for the main metabolic pathway to provide sugars for biosynthesis of the cellular components. However, it causes lower efficiency of the cell mass and PHB. Then after we did the material characterization, the molecular weight of the PHB from glycerol is lower than from the PHB from glucose. However, PHB from glycerol has similar physical properties to the PHB from glucose. Therefore, the glycerol PHB could be considered to apply for the industrial production.
Mahalo, thank you for your watching. Hopefully this paper will be valuable for your research. Enjoy your reading.